So I just wanted to record the examples that we're going to be doing on Zoom of angles of elevation and depression. The main thing to note is that your angles are always going to come from a horizontal line going across. It's not letting me write. So angles are always going from like a horizontal straight line across like that. So an angle of elevation is formed by this horizontal line and going upwards. This would be an elevation angle. And an angle of depression would be formed by a horizontal line but then going downwards. This would be an angle of depression. So elevation, think up, like when you smile, your line goes up. Depression, think you start straight, but if you're getting depressed, you're sad, you're going down. So we'll go through about 4 examples of each together. And again, this will be on Zoom, but I'm not recording from Zoom. Okay, so the first one we have a person, Casey, states the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. She is 6 feet tall. How far is she standing, or how far is he standing from the base of the lighthouse? So let's draw like a little person here. You don't have to. We know he's 6 feet. We'll draw our lighthouse here. And then the line of sight would be starting from like a horizontal line there, coming from their eye, going up to the top of the lighthouse. And it says this angle is 58 degrees. We know the lighthouse is 84 feet tall. So this whole thing over here is 84. But our triangle just involves this little piece here. So if that's 84, and she's 6 feet tall, or he's 6 feet tall, the leftover would have to be 78. So we're working with this triangle here, and we want to figure out this distance between the person and the lighthouse. So we are going to go and label our triangle. So first would be hypotenuse, but there's nothing there. So we're just going to label across from the angle is O, the other side is A. So we're using tangent, TOA. So tangent of 58 equals 8 over x. And then you're just doing your cross multiplying to solve here. So over 1, and we'll have x tangent 58 equals 8. And then to solve, you'll just divide by tangent of 58. So it's 8 divided by tangent of 58. Which you can plug into your calculator, and I'm just going to go and grab mine really quick. Okay, so I put that in, 8 divided by tangent 58, and we get about 5 feet. So this person is 5 feet away from the lighthouse. Okay, next we have the angle of elevation from a kicker's foot on the football field, so straight line first, to the top of a goal post. So here's your angle, here's your goal post, here's their foot, the ball. This angle here is 17 degrees. And they're standing 131 feet away. And we want to find this height here. How tall is the goalpost? So again, let's label. Hypotenuse, again, there's nothing. So we have across from the angle is O. 131 is A. Sorry it's kind of messy, but it's hard to write and also video at the same time. Alright, so again, we're using OA is TOA, which is tangent. So tangent 17 equals x over 131. Cross multiply, you have x equals 131 times tangent of 17. And again, just put that into your calculator. And we end up with about 40 feet. So the goalpost must be 40 feet high. It's pretty tall. next one. Leah's mom is standing at the bottom of the slide at the playground waiting for her to slide down. So we can draw it. Here's the slide, right? Here's her mom is somewhere over here. Right angle is here. The angle of elevation from the bottom of the slide to the top is 46 degrees. So that would be from here to there, bottom to top of the slide. And the slide has a vertical height up and down of 9 feet. We want to find the length of the slide. So now X is here for our slide. So again, across from 90 is H. This time we do have it. Across from our angle is O. We only need 2 sides to solve. So we have OH, which is so. So we're going to use sine of 46 equals opposite over hypotenuse, 9 over x. Put this over 1 and cross multiply. So now we have x times sine 46 equals 9. And to get x alone, we're going to have to divide by sine of 46. And just put that into your calculator. 9 divided by sine 46. And we get about 12.5 feet. I usually just round to the whole number unless it's 0.5. But I'm not going to take off points for your rounding. Okay. In another elevation, when we have a dog standing 5 feet from the base of a tree looking up at a cat that has climbed in the tree. So here's our tree. Somewhere up there is a cat. Over here is the dog. We want to find, oh, he's 5 feet away from the base. Base is the bottom. And the cat is 16 feet in the tree. And we want to find this angle down here. So again, we're going to label everything. Across from 90 would be H, but there's nothing there. Across from the angle is O, other side is A. So we have TOA or tangent. So tangent of the angle is 16 over 5. So remember, when we're finding the angle, we're going to take tangent inverse of the ratio. So I'm just going to put that in my calculator. Tangent inverse of 16 over 5 gives me about 72.6 degrees. Again, make sure that you're working in degrees and not radians. Okay, so we're going to move on to some angles of depression now. Okay, so for angle of depression, again, always it's very important that you draw first a horizontal line, because the angle of depression has to come from a horizontal line first. So it would be this angle in here, in between the horizontal line and the diagonal line that you draw. So first problem, we have a lifeguard sitting in a platform, kind of like that picture. I'm just going to recreate it. Looking down at a swimmer in the water. The lifeguard's line of sight is 8 feet above the ground, so we're putting 8 here. And the angle of depression to the swimmer is 18 degrees. So this is not the angle of depression. That's just some other angle. Your angle of depression starts from a horizontal line that you can imagine, and then it's formed by that line and the diagonal line. So this is 18 degrees, and we want to figure out this distance. So you can always make these ones into like a rectangle and label the opposite side. So if the bottom is X, the top is X. If the left is 8, the right is 8. So now we're working with this triangle here. We can kind of ignore this one because we don't know any of the angles. So again, we start by labeling what we know. So across from 90 would be H, but we don't need that length. Across from the angle is O, the other side is A. And then you're just writing and solving your equations as we have been. So tangent, OA is tangent, right, of 18 equals 8 over x. So that would give us x times tangent 18 equals 8, and x will be 8 divided by tangent of 18, and which we can just put in our calculator. giving us 24.6 feet. So that's how far away they are. Usually you'll see a lot of these involve tangent because it's very rare that you actually need that diagonal line for something. Okay, now we have a pilot and a helicopter, so I'm going to put like an H. Well, I should just write helicopter. Spots a landing pad below, so here's the landing pad. And he sees this landing pad. The angle of depression is 73 degrees. So you have to draw a horizontal line first. So horizontal with the diagonal is 73 degrees. The horizontal distance is 1,200 feet. So the horizontal line is 1,200 feet. We want to know how high the helicopter is flying. So basically this height and this height over here in the triangle, I know it's not perfect, but this height will be the same. So we want to figure out this height. Altitude just means height. So again, we can label what we know. So across from the 90 degree, which is technically here, would be H, but we don't need it. Across from our angle is O, and the other side is A. So again, we're using TOA or tangent. So tangent of 73 equals O, which is height, over A, which is 1,200. And then that would give us H equals 1,200 times tangent of 73. And you need your calculator. And we get 3,925. So it should be 3,925 feet. Next one we have building A and building B. So A is 480 feet, B is 654 feet. So here we have 480. This whole thing is 654. The angle of depression from the top of B to building A is 42 degrees. So first you have to draw a horizontal line at the top. Always draw a horizontal line. Then you can draw your diagonal line connecting the top of building B to the top of building A. And that angle in there is 42 degrees. We want to figure out how far apart are the buildings. So that would be this distance here, or if we complete the rectangle, this distance here, and we can use this top triangle. And we also need to know this side here. So if the whole thing is 654, this bottom part is 480. We just have to subtract to figure out what that would be. So 654 minus 480 is 174. And then we're just dealing with this top triangle. If that's 174, this is also 174. Actually, blue and purple look too similar. So we can ignore all of this stuff and just deal with this triangle up here. So we have opposite and adjacent again. So we're using tangent. So tangent of 42 equals opposite 174 over x. So x times the tangent of 42 equals 174. And then we have to just divide by tangent of 42. So 174 divided by tangent of 42 gives us 193 feet. And I believe we have one more. Okay, so Zach is standing at the top of a lookout tower and spots a water fountain below. Here's the water fountain somewhere down here. He's seeing it. If the lookout tower is 75 feet tall and the angle of depression is 28 degrees, so we have to draw a horizontal line first and then connect that to the water fountain. This angle up here is where your 28 degrees goes. And we want to know the horizontal distance, so we want to figure out this distance. So we can just make our rectangle. if that's 75, this is 75. We're just assuming everything is perfect here. It's very hard to draw on this. And there's our angle. And then you're just solving the problem. So we're ignoring this bottom triangle and just looking at this top one. So again, we have O and A, and we don't need this extra part of the line that I drew. So again, we have tangent of 28 equals 75 over x. So we'll have x tangent 28 equals 75, and then just divide by tangent of 28. So 75 divided by tangent 28 gives us 141 feet. So of course, if you have any questions, just email me, let me know, and have a great day.